Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, let's continue on question 2 under May June 2022 question paper. Now, it says to us a man faces difficulty while swimming in a dam. During the rescue operation, an inflated tube attached to a helicopter by a rope is dropped from a helicopter, right? Can we see that? Yes. The man of mass 70 kg holds onto the inflated tube of mass 4 kg while the helicopter is flying horizontally. Okay, flying horizontally at a constant speed. What does constant speed tells us? Now, constant speed tells us that acceleration is equal to 0. An average frictional force of 300 newtons is exerted on the main tube combination while they are dragged horizontally along the surface of the water by the helicopter. The rope makes an angle of 50 degrees with the surface of the water as shown in the diagram below. Assume that the rope is inextensible and massless and the water of the dam does not flow, okay? And now, they say to us, state Newton's first law. What does Newton's first law say to us? Remember, it says to us, a body will remain in a state of rest or motion at a constant velocity unless a non-zero net force acts on it. Okay, let's try to rewrite that. And actually, no, you know your definition. For 2 marks, just know your definition. Okay. 2.2 says draw a free body diagram of the main tube combination while they are being dragged. Now, the free body diagram from here, I can say this is my body. Okay, from the tension, this is my body. FG, normal force, like that. So it's gonna be something like this. My free body diagram will be like so. Okay, the first one I'll be having it is this force. Okay, that one force we're gonna call it force of the rope, which is my tension. Okay, then I'm gonna have my my FG here. Okay, I'm gonna have my normal force because now it is on. Okay, normal force. Then lastly, my frictional force. Lastly, my frictional force for 4 marks. Okay. But now what I like to do it is to break this into its component. This is for 4 marks. When you are asked to draw, you do this. You are done. Then for calculations, you draw the other one aside where you will say, all right, my tension can be broken into Tx as well as what? Ty. Like that. Then I'm going to ignore this one. Okay. All right. So for my calculations, I'm going to use this. Now remember they are moving at constant velocity. Still remembering that acceleration is 0. Again. Yes. Now calculate the tension in the rope. How can I do that? I can say now F net it is equal to MA, which it is equal to 0. I can just say F net is equal to MA now. But now I'll choose choice of direction. Since well they are moving in that direction, I'll choose going to the left as positive. Since they are moving towards the left, right? Now, what is my F net? So it's gonna be Tx, but I want you to see something here. This is Ty, this is Tx. Can you see that? This is T, tension or rope. Now, if I want Tx, Tx will be adjacent divided by hypotenuse. So Tx will be T cosine of 50 degrees, your trigonometry. Okay, so I'm gonna say instead of writing Tx, I might say this T cos 50 degrees minus friction, it is opposing the motion. It is equal to 0. Why? Because now my acceleration it is 0. Okay? When I continue with my calculation thereof, I'm gonna get something like allow me to continue here on this space here. So it's gonna be T cos 50 degrees minus 300 is equal to 0. Then do you all agree with me? T is going to be 300 to the other side, divided by cos 50. Okay, then my tension in that particular case, the off will be something like 466,72 newtons. Okay, this is my tension force, the off. Okay, I'll put it here for now. Let me erase this. I'll erase. Okay, this is my tension force. Okay, now the question says to us, how will the answer in question 2.3 rather change if the helicopter accelerates now? Remember now, if the helicopter accelerates now, remember now, at first we had Fx being equal to the tension, because now if they're moving at a constant velocity, remember constant velocity means these forces here are balanced. Again, constant velocity, yes, an acceleration of equal to 0 and constant velocity means these forces are balanced. But now if there is acceleration towards the left, I want you to see something. If my object accelerates towards the left, it means now tension in the x direction, it is now greater than friction. So it means it causes now to increase the speed. Okay, so now it will increase, my tension will increase if my acceleration increases, because now it will be Tx minus friction is equal to ma. For us to have an acceleration in that direction, that off, it means we have a net force. Okay, it means we have a net force, and now Tx should be greater than F. Okay, yes, Tx, not T. Take note, Tx, it is equal to a friction in this case, but now Tx, if there is an acceleration, it will be greater than F. So when you answer this, you're gonna say increase. Why is that case? You're gonna say Tx is greater than friction, or you can say F net increases. F net increases. Now there's an F net. Again, F net increases, or you can say F net is not 0. F net, it is not equal to 0. So hence there is an acceleration thereof. So yes, I think they are accepted thereof. I don't know, you can check the marking guideline, but I think this one should be more or less something like that. Okay, now let's move on to the next question. Now it says to us, in another rescue operation, the inflated tube of mass 4 kg is dropped from the stationary helicopter gear as it strikes the water at a speed of 16 meters per second. So here, it strikes the water with the velocity of 16 meters per second. Now, the tube sinks. The tube sinks vertically downwards into the water to a depth. So when it reaches this point, I want you to see something. When it reaches this point with the velocity of that, it will sink. The tube will sink towards the water, but at some point after 0.8 meters, the velocity here will be 0 meters per second. Why? Because now, can you see it will be the gravitational force. Let's say here is the inflated tube now. As it moves down, this is force of gravity, right? Moving it down. But due to, remember when you let's say a practical example, when you sink inside water, do you agree with me that there is a force that lifts you up, right? There is a force that lifts you up. So as it sinks down towards the water, there is this force that try to oppose the what? To oppose the what? The gravitational force there. So it means we will be having an upwards force. And that upward force, it is always greater than gravity. Why? Because if that was not the case, we wouldn't be able to swim, because now we will be sinking inside water instead of coming back. Okay, so I want you to realize something. After 0.8, or okay, they even say as into water to a depth of 0.8 and then rises to the surface. Okay, so now it will come from this point where V it is 16 meters, it will go down, and at some point your velocity will become zero, where it will stop going down and it will do what? Go up. Okay, I want you to take note of that. So this, it is our V initial, V final. This is our distance, change in y. Okay, let me remove. This is our change in y. Okay, now they say to us this question, it is hidden, but please bear with me. It says calculate the magnitude of the average upwards force. So we wanted this one. Upwards force exerted on an inflated tube while it is sinking. Assume that the average upwards force is constant for the motion. Okay, it is constant. But now it means we have to apply Newton's first law, Newton's second law, where it says now to us F net it is equal to ma. Now, there is an acceleration there. Why? Because it moves from 16 meters down, but the acceleration is deceleration in this case. Our acceleration decreases. Why? Because it moves from 16 meters per second to what? To 0 meters per second. Can you see that? So I'm expecting a deceleration. Okay, but there is an acceleration. So, but I need to calculate this acceleration since I do not know it. Okay, but now how can I calculate that? I can say now, okay, I have initial velocity, final velocity, change in y. Remember, vertical projectile motion applies. Yes, it is question 2, Newton's laws question. You're expecting Newton's laws, but remember they are all under mechanics. They can put them wherever. Okay, especially in May. They like to do that in May. So I can say Vf squared it is equal to Vi squared plus 2a change in y. This is my formula again. Okay. And now take note that they said assume the average upward force is constant. So it means its acceleration is constant thereof. Remember this formula, you only use it when the acceleration it is constant. So if the force is constant, remember force is directly proportional to acceleration. If the force is constant, acceleration is constant. If the acceleration is not constant, you cannot use this formula. Okay, yes. What is my Vf? My Vf it is 0 squared Vi, it is 16 squared plus 2, 8 is what I'm looking for. What is my change in y? Change in y it is 0, 0.8. Okay, then when you do your mathematical gymnastics, a will be equal to negative 16 squared all divided by 2 multiplied by 0, 0.8. I think you get something like let's see, acceleration of negative 160. Negative 160 meters per second squared now. Okay, let me take this here. It's fine, let's just remove it. Okay, now that I have acceleration there of negative 160 meter, and now remember I said the acceleration will be negative because it is deceleration in this case there of again. Therefore I can come here and say okay, F net is equal to ma now. But what is my F net? Remember I said it is moving like this. We have an upwards force, okay, and we have what? Fg, okay? So it means I'll take upwards as positive. Similarly here, I took what? Okay, I did not choose a choice of direction here. Okay, I choose upwards as positive. Downwards as positive. Yes. Okay, I took downwards as positive here. Why? Because now yes. Why did I say I took upwards downwards as positive? Because my object was displaced downwards. Okay, so 0.8 was going to be positive because it is displaced downward. If I chose upwards as positive, it means this 0.8 was going to be negative because it is downwards and I'm choosing upwards as positive. So yes, I hope you are following that. Also, this Vi it is going down, so hence it is positive. So I'll also choose downwards as positive here. So what is my F net? So remember, if I choose downwards as positive, it means now I'll say F net it is equal to Fg moving downwards minus my F up. It is equal to Ma. Am I in a position of substituting? Yes, but I can change this to mg. Okay. Then what is my mass? Remember, you're talking about the mass tube now. It is going to be 4 multiplied by 9,8 minus force upwards. Okay. Force upwards. Okay, and they wanted the magnitude. Okay. But now I want you to take note, the force upwards that I get should be negative also. The force upwards should be negative because now I took downwards as positive and your net is moving up, so it should be negative. Then I'll just take the magnitude fail. Negative, negative 160 again. Like that. This is the acceleration I calculated there. Then when I want my F up, I will take it to the other side and take that to the other side. So it's gonna be a 4 multiplied by 9,8 plus this one. Okay, so when you do your mathematics very well, you'll get an answer of negative 679.20 newtons. Yes, because now we chose downwards as positive, but your net is moving upwards. But now the examiner wanted the magnitude. You'll say therefore force upwards, it is equal to 679.20 newtons. That's all that was expected from you, basically. So for nice 5 marks, fella, for nice 5 marks, it is you substituting into the acceleration formula and coming here, F net it is equal to ma. Okay, then you substituting the left hand side and the right hand side, now the off. Okay, using the 100, negative 106, then the final answer F up with a no negative sign. Okay, this was nice 5 marks. Here for increase, 1 mark. For any of these reasons, 1 mark. Then yes, Freebot diagram, you always know 4 marks. Fine. Wedding, stating it is 2 marks. For this one, calculating the tension, you saying Tx minus friction, it is equal to 0, it was 2 marks. Then calculating Tx, another 2 marks. Okay, yes. So that's all for question 2. Under May June 2022 question paper. Let's move on to question 3, vertical projectile motion now. Thank you.